Alright, so we are learning graphs of exponential functions. Part 1 starts on page 182. On the left-hand side I have the work. On the right-hand side I have the calculator once again. So we'll be using the calculator, and this is the FSA calculator. Okay, so again, we should all be on page 182, and let's just start with the first question. Let's review what we've learned in the previous videos about exponential functions. So first of all, an exponential function can be written in this form right here, and this form is called the exponential function. So far we've learned, like I mentioned earlier in the unit, we've learned how to draw a straight line, we've learned how to draw a curved line, a U, which is a parabola, so a straight line, and now we're learning a curved line like so. Okay, and each one of these had a distinct formula. So y equals mx plus b for a straight line. Okay, that's the formula for a straight line. The formula for a parabola is ax squared plus bx plus c. And now this new one is the one I just highlighted, a times b to the power of x. Okay, and like I mentioned, they form these like L's, or these half a U's. Okay. So, which key feature of the exponential function does the a term represent? So what is the first term, a? What does this a represent? Okay. Now that represents the y-intercept. Okay. So whatever a is, that's your y-intercept. That's where it's going to cross the y-axis. Okay. Now, which key features of the exponential function does the b term represent? So now we need to figure out, what does this b represent? Okay. Now that b represents the common ratio. Okay. And we talked a little bit about that in the first video. Common ratio is how much, almost like the rate of change. How much is this changing each time? Okay. All right. Let's drop down to the next page. Let's practice. So consider the exponential function y equals 2 to the power of x. So first of all, we have 2 to the power of x. So like we just learned, this number and the number attached to x is what we call b. So this is your b to the power of x. So the 2 and the x are the b, and the x is the x. Okay. Therefore, is there a 1? Well, yeah, there is a 1. And if there's no number, it's really just 1. So what is my y-intercept here? My y-intercept is 1. So I put a dot at 1 because that's what we need to do. We need to sketch this out. So we put a 1 by the y-intercept. Okay. So here's how this is going to work. You're going to make a x and a y chart. Okay. And we're only going to do 4 numbers. One of the numbers has to be the y-intercept. And since you already have the y-intercept, it's 0, 1. Okay, so all that it is just the first term. Okay, so next we're going to use our calculator to find the next 3. Okay, you're going to make 2 of them. You can make 2 of them positive and 1 of them negative. So let's do a -2, a +2, and a 4. Okay, so on the right hand side, I'm going to use the calculator. So we're going to input this as 2, and I'm going to press the x squared, but I'm going to I'm going to put my cursor over the 2 and erase the 2. Now I'm just going to input the new value. So the first value we're going to put is -2. And that answer is 0.25. Okay. So I'm going to go back to the calculator and erase the -2 and put a +2. So when I put a +2, it changes to a 4. And last but not least, we're going to change that last number to a 4. So I'm going to erase the 2 and change it to a 4. Now I'm at 16. All right. So let's graph these on the graph. So -2, which is this one right here, and 0.25. So it's going to be closer to the bottom. So it's going to be like right here. Okay. All right. Now 2 to 4. So 2 to 4 is right here. And 4 to 16. Well, 16 is probably going to be somewhere way up here. And you can do it off the chart. That's fine, off the graph. Now you're going to connect your dots. So connect it from the highest one to your lowest one. And then it's just going to continue like that. Again, they don't have to be perfect. It just has to look like that U, or that half a U. Okay? So, is the graph increasing or decreasing? Well, if you look at the graph, it may look like it's like a slide, like it's going down, but it's actually going up. Okay? Every number is increasing because it's increasing on this coordinate plane. So what I mean by that is it's increasing here. Notice how the numbers are getting higher and higher and higher. Okay? Over here, the numbers are going lower and lower and lower and getting really close to that bottom. Therefore, your graph is increasing. The graph is going up. So it is increasing. And it's increasing again because all of these numbers on the highlighted area are positive. So therefore, it's increasing. Okay? So describe the end behavior of the graph. So as x increases, so it's saying as your x increases, so as these numbers increase 2, 4, 6, 8, 10, 12, what's going to happen to my y's? Are they going to go down? No, they're going to go up, right? So as my x increases, my y also increases. Okay? Now, as x decreases, so as my x gets smaller and smaller and smaller, what happens with my line? Well, my line gets really close to 0. So as this decreases, it approaches 0. Okay? And notice how my graph is really close to 0, but it does not touch. Okay? That's what an exponential function does. It gets really, really close to 0. Okay? So the point of this graph was to show you when you have a positive number, the graph is going to increase. Okay? When you have a positive number, your graph increases. Okay? Let's move on to the next one. Consider the exponential function y equals 1/2 x. Okay? Sketch the graph of the exponential function. So this time we have a y equals a times bx. Again, is there an a? No, so it's just 1. Is there a b? Yeah, it's 1/2 and x. So remember, a represents our y-intercept, so I can easily just put that on 1. And now let's make an x and y chart. X and y. We already have our first point. The first point was 0, 1. Now, you can use the same numbers, doesn't matter, up to you. We're going to use, we'll use negative 1. I'll use another negative 3. And last, I'll use a positive 3. Okay. This time I'm using 2 negatives and 1 positive. It doesn't matter which numbers you use, just as long as there's a negative and positive. If you use 2 negatives, that's fine. If you use 2 positive, that's fine as well. All right, so I'm going to clear my calculator. I'm going to put this in as my fraction. So I'm going to put the fraction first, 1 over 2. And then we're going to put this to the power of 2. But instead of me putting to the power of 2, we're going to first start off with the power of negative 1. Okay? So, when I put to the power of negative 1, my answer gives me 2. So 2 goes here. Alright, let's erase that negative 1 and now put a negative 3. And my answer here is 8. Now let's put a positive 3, so just erase that negative, and you get a 0.125. Notice how on this one, the bigger the negatives, the bigger the number. The bigger the number, the smaller the point. Okay, 0.12, that is so close to 0. Alright, So let's graph these. So I'm going to start with -1 and 2. So -1 and 2. Then -3 and 8. So -3 and 8. And last but not least, 3 and 0.125. That's really close to the line now. Okay. So I'm going to start at my top and go to the bottom. And it's going to go really, really close to the x-axis. Notice the difference between this one and the other one. So this one, it starts at the negative side and ends at the positive side. Okay. This one, your graph starts at the negative and goes up. So starts at the positive, goes up, starts at the negatives, goes up. Okay. So the graph's kind of flipped. So is the graph increasing or decreasing on this one? Well, on this one, your graph is actually decreasing. Okay, so whenever your graph looks like this, your graph is decreasing. Whenever your graph looks like this, your graph is increasing. Okay, so on this one, as x increases, so as your x numbers increase, what happens? Well, your y's approach 0. Approaches 0. Now, as x decreases, so as x numbers get smaller, so -2, -4, those are small numbers because they're negatives. So what happens with my y's? Well, my y's increase. So notice, whenever your x's decrease, your numbers on the y's get bigger. When your numbers on the x increase, your numbers on the y's decrease. Okay? So notice the difference with this one. This one, you have a 1/2. So your number is less than, so b is less than 1. So whenever b is less than 1, your graph is going to decrease. Whenever b is greater than 1, your graph increases. Okay? So whenever your number is smaller than 1, it's going to decrease. Whenever it's bigger than 1, it's going to increase. All right, and let's move on to number 3. Number 3 says consider the exponential function or exponential equation y equals -2x. Sketch the graph of the exponential function. So on this one, we have a -2. So this one, your y is going to equal, this one is actually different. It's going to be -1 times 2 to the power of x. So your a this time is -1. Your b is 2. So your common ratio is 2. All right, so therefore your y-intercept is going to be -1. Okay, so now I do my x and my y's, and your first point again was 0, -1. Now on this one, we can go ahead and I'm going to do 2 positives and 1 negative this time. So we'll use 2, we'll use 3, and we'll use -2. Okay. All right, so I'm going to use my calculator on the right hand side. So we're going to input this as -2. Okay, and the reason I'm not doing parentheses over this one is because the parentheses is it's not going to include the timesing the -1. So remember, a is -1 right here. So you're going to leave it as with no parentheses, -2. So continue to do that in these problems. -2 to the power of 2. So you see how that answer gives me -4. -4. Okay, let's change that 2 to a 3. That answer is -8. Now let's change that 3 to a -2. That answer is -0.25. So let's graph these 2 points, 2 and -4, 3 and -8, and -2 and 0.25. And that's about like right here. Oh, I'm sorry, it's a negative, so it's a little bit below. Okay, so I take my dots. Okay, as you can tell, this graph is totally flipped onto the other side. So, is the graph increasing or decreasing? Well, that's pretty easy. We can all tell that this is decreasing because the entire graph is on the negative end. Okay, so as x increases, so as my x numbers increase, what happens to my y's? Well, they start to decrease. So as my x numbers get bigger, my y numbers get smaller. Okay, and as x decreases, so as my x numbers negatives go negative, what happens to my y's? Well, they approach 0. Okay. Therefore, whenever we have a negative, the entire thing is on the negative end. All right. That's it for this video, and I will be checking these notes.